So if the application wants to implement more security layer on top of first factor authentication, so then probably the user has to authenticate with another factor, which is a strong authentication factor like OTP, biometrics, offline OTP. So which is like more secure than password. So which are dynamic, and this comes under some this comes under a category which user holds. So in multi-factor authentication, we probably have three things like something you know, something you have, something you are. So biometric authentication falls under something you are, because it is so the way the I mean it's basically us, right? So like however our face is, the face is being authenticated. So that's why it says something you are, and password is like something you know, because you already know this your password. You might have created it, and OTP is like something you have. So OTP is something you receive in your mobile device or to your emails. So so that's why it's something this that's why this OTP falls under something you have. So whatever I'm saying, right? These three categories can be visible in the transmit side when we are creating an authenticator in transmit side. So it will ask you to select options like which category the authenticator that you are creating falls to, so that it determines whether you are in a 2FA or you are in a 1FA based authentication. Something you know always falls under 1FA, and everything else falls under 2FA. And authorization. So once the user's identity is established, or once the user verification is done, there are too many windows getting open. Yeah. Okay. So once the user's identity gets established, now the application has to decide which uh, resources the user can authorize and which resources user cannot authorize. And this control will not be at the application side. So the backend systems help the client application to explicitly tell that the user can access only this particular resource. And how exactly the access delegation is done? So based on two methodologies. One is like RBAC, role-based access control, and the other one is attribute-based access control. So normally enterprises deal with the role-based access control. For example, if the user is part of a group, particular resource group, and the resource group will be assigned permissions accordingly. For example, uh, I'm a user who is part of admin group. So admin group has unprivileged access to any system, because he's an admin, right? He should be given access to all the resources in the system to do any updates, or to delete a user, to block a user, to unblock a user. So the admin has the highest privilege. So if the user belongs to admin group, he will be given the highest privilege. So the authorization to the users who belong to admin group will be having unrestricted access. Similarly, if the user who belongs to support group will be having access only to few limited resources, so he will not be having access similar to the admin. So whatever the activities admin can do, the same activities support a user belonging to support group cannot do. And similarly, we have operations. So operations can do activities which support group users or even admin could not do. Probably admin can do everything, but operations will be given little privileged access. So all these access controls are done based on user group assignment. So this is one way of defining access or authorization to a user on what he can access and what should not access. Okay. And there is other concept called ABAC, attribute-based user control, like role, which role he belongs to, which department, and which files he can access, which files he cannot. So like this, and also even the location related attributes. So and read, write, delete. So each and everything is considered here in the ABAC to assign permissions to a user. So this is like more granular or fine level access, I would say. And this is basically role based access. So based on the role, user will be permitted to perform operations on an application. So this is authentication and authorization. And in Transmit, we'll be mainly dealing with these two, uh, authentication and authorization most of the time, because Transmit web applications that we create for any banking client, basically, any. Can somebody please go on mute? There's a background noise. Thank you. Yeah. So, because we'll be dealing with the web-based applications in Transmit, which, I mean, where where a banking application, say a credit card-based application or a normal online services page, where the user normally log in every day to view his account, perform his transactions. So all this, so in order to tell the client that the user is authenticated, now the user has these permissions, so only the user can do this. So for example, say some users are blocked to update their profile because Transmit detects that this user could be a high risk user. So I will not allow this user to do any profile updates till next 30 days, because this user have done profile updates in last 3 months, or say this user have been updating his profile very frequently. So I might have a rule in my journey which says that if the user has done profile updates, is doing profile updates very frequently, then I suspect it is a fraud. Then probably what I would do in the journey side, I would make some changes to the DB, saying that we have to keep this user under risk for some days. So once I mean, again we'll monitor this user for another 3 months, or say 1 month, and probably if everything is good, then probably we'll switch the user from risk to low risk. So, and based on this, also the roles can be, I mean, not roles, the access can be defined. So from the journey perspective, so it is completely depending on the data that it has. So based on this data, it can tell the client that do not give access to this user to control his profile updates or profile information, or update any changes to his profile information. So maybe if a phone number is changed in his profile, it is going to be a high risk transaction for the high risk transaction for the actual user. So there might be credentials compromised, and the other user might be impersonating the actual user, right? So, and Transmit suspects it as a fraud based on the rule engine it has created. I mean, based on the business requirement, it has a rule engine created, and this rule engine basically indicates that this could be a high risk transaction, and the user will be given limited access to his account. So that way, authorization can be controlled. So authentication, if even if a user impersonates, but still authorization can be controlled this way. Okay. So this is all about authentication and authorization. Next, I would talk about identity provider. So identity provider and service provider are terminologies that we'll be using mainly when we deal with the OIDC based applications and SAML based applications. Okay. So we'll go one application wise we'll be dealing. So first we'll be dealing with server API, then probably we'll move to web, then OIDC, and then SAML I would see if I can uh, provision in the web SDK side, because for SAML we need a little different functionalities. So yeah, but I would show each and every endpoint that needs to be called from client side for SAML. Okay. So identity providers are the systems that authenticates and authorizes the user. So here the identity provider bears the responsibility to hold the user store, to authenticate the user, and authorize the user. So it's a centrally managed identity system, I would say. So normally when we are logging into third party sites, so we click um so the third part so we are afraid to log in, we are afraid to provide our credentials to third party sites. So the third party sites offers the user to verify himself through popular IDPs like Google IDP. So there it will show you like login with Google IDP, login with Azure, login with Okta, login with Salesforce. And for social platforms, you will have login with Facebook, right? So these ID, so these gains, or I said these identity providers basically manages the user store. So Google, so if, for example, say I'm logging into a third party site, and Google would say, hey, I can authorize this, I can authenticate and authorize this user. So please provide an IDP option in your screen, so that so that user, when user comes to me, I will try to see if he has an account, if he has an account created in my identity provider side, and if there is no account, then probably I will return an error back. So third party site agrees, okay, fine. I don't need to have the hassle of maintaining the user base, and also I don't need to again configure a database to hold all these users. Then it will simply integrate Google as a plugin, and the user who clicks on Google login with Google IDP. Uh, so Google authenticates this user because everybody has Gmail account. So Google authenticates this user, and then returns an access token back to the third party site. And now this third party site uh, will validate this access token and see user has what permissions, and user doesn't, and what pages the user can access, and which page the user cannot access. So all this information will be injected in the OID, or in an access token, or an ID token. If they don't if the third party side doesn't want to deal with an ID token, then they deal with an access token to delegate the access. So access tokens are only to delegate the access. ID token is to establish that the user's identity has been verified properly, and in recognition to that, I'm returning an identity token. So we'll come to that tokens part in detail. Okay, so that is an identity provider. So identity providers are responsible to manage and verify, validate, and authorize. So all these three operations will be performed by identity provider. So service provider, or we can call it as relying parties. So these service providers are nothing but the client applications. So the applications that depends on identity provider asking their users to be verified by identity provider. So that is, I mean, so whoever depends on the identity provider, right? Those are service providers. So here in our case, I have told you about a third party site. So you might be randomly blogging in the internet. So you might have clicked a link, and it asks you. For example, best example is Quora. Okay, so when you log into Quora, which is where like most of the questions are answered, right? So like social, it's a social platform. So Scora always asks their users to log in to enhance the reading experience. So it'll so you don't want to create an account in Quora, but you trust Google. So there you have a Google IDP available. So you just click on Google and get yourself authenticated, and you will have access to Quora, right? The same thing. So here Quora is service provider, Google is the identity provider. So that's how you can relate. Okay. And yeah, last two terms, IDP initiated flow and SP initiated flow. So like normally the flow should be either initiated from an SP side or from an IDP side. So in an SP initiated flow, what happens? The user first accesses the platform, and the platform will now initiate the request to IDP to authenticate the user. That is SP initiated flow. But in an IDP initiated flow, the flow is initiated from the IDP side, not from the service provider side. So uh, yeah. So for example, so in SP initiated flow is very straightforward. For example, say a user is logging into an organization, and so he has a single sign-on login provision. So he enters his SSO or single sign-on ID, and then clicks on login. So and the request goes to the IDP where user gets validated, and the access token is returned back. And based on the access token, he will be able to see what applications he can access inside the portal and which applications he cannot. So that is an SP initiated flow. It's a service provider initiated flow. SP stands for service provider. IDP stands for identity provider. Okay. So in in identity provider flow, probably, for example, say you have logged into Google. Okay. So you have a Google open in your browser, and inside once you authenticate with your Gmail account, So on the Google, probably you will see options like Google Drive, Google Mail, and Google Photos. So all these applications you will be having access. So now here Gmail, Google Photos, YouTube. So all these are service providers. Okay. So here, because they are not good doing any authentication for you again, right? Because already Google has done authenticate. Already Google has authenticated you. The moment you open Google, so it'll ask you to authenticate. So or sign in, right? So that is IDP initiated flow. So like in simple terms, you can relate to that example. Okay. So the in IDP initiated flow, the authentication starts from IDP side. In SP initiated flow, the authentication starts from service provider side. So service provider is a client application which requests to authenticate its users. Okay. So hope you're clear. If you're clear, I can move on to server API application. Okay. I will take it as no questions. Okay. So server API applications in Transmit are very quick to develop and expose to end user. So Transmit Server API applications serves RESTful representations of Transmit services. That means we develop a journey, we have our own custom logic, we will create our own destiny tree model, everything done, and then probably we can expose this entire journey as a service through Transmit Server API out of the box endpoints. Okay, and so normally where Server API applications in Transmit are used. Okay. So, like just going back one step. So, yesterday we have recapped about applications. So, what applications are entity, or I would say a container that holds these journeys. Okay. Like how I related one example in Java. So, in Java we have package. Under the package we have multiple classes. So, package is holding all these classes as a package. It's a package manager. Here it's like a journey manager here. So, the applications in the so the application containers holds these journeys, and when we make requests to transmit server always asks the user which application you want to connect, and inside the application which journey you want to connect. So that's how we are tying up journeys with applications. So here applications have application IDs and journeys have journey IDs. So both these identifiers are unique in Transmit. So there you can create n number of server IP applications. Say you have 5 clients. So Gap, you have a Gap, TJX, Citibank, you have Wells Fargo. So all these are your clients. For each client, there might be a different logic you want to develop based on their business requirements. So you don't want to mix one application logic with other application. So you'll create multiple applications, and each application holds a different set of journeys. So for client one, I have server API underscore client one application created. For City, I will have City underscore server API. For Wells Fargo, I'll have Wells Fargo underscore server API. So this way, you can create multiple applications, and each application is isolated from the other one. So there is no link between these two applications. Each application runs uh, based on the rules configured, based on the journeys it has, and based on what authenticators you configured. So it's completely different. So each application is like uh, a different configuration file in Transmit. Okay. So it's at the end of the day, it's a JSON file, but it for Transmit it's a configuration file. What you configure is what you get exposed to the end user in Transmit. So this is an application. So application is an entity, or we can call it as a container that holds all the journeys. So it ties up the journeys with all the artifacts in Transmit. So if a journey calls an external connection, a journey can call it a type list. Journey can call if scoring rules. I mean, or the profilers. So so the application controls it. So it's like it manages the life cycle of a journey. So that way we can put it. Okay. Hope applications are clear in Transmit. So whether it can be any application, server API, web, OIDC, SAML, or workstation logon application, the application lifecycle is same for all the applications. The execution trigger, the execution mechanism, everything is same. And Transmit uses this is the commonality for all the applications. But only difference is the way the user interfaces with Transmit is different. Okay. Yeah. So coming to transmit server API application. So these are completely backend to backend API calls to the journeys, I would say. So you don't need any interface to interact with the REST APIs. All you need is a server out of the box API endpoints exposed by transmit. The moment we start the server, these endpoints are accessible to the end user or outside world, I would say. So here there are two things. Okay. Let me show you the endpoints I'm talking about. Yeah. So these are the endpoints that is exposed for server API. Okay. So server hyphen it. Sorry. Slash authenticate. Yeah. This is the right endpoint convention. Okay. So like slash authenticate slash assert slash anonymous hyphen invoke and slash logout. So these are the four endpoints that we can use to interface with server API journeys. So the first endpoint is used to call a transmit journey, and the second endpoint is used to resume a pending session. For example, user is getting authenticated, and user is asked to enter his OTP or password in the next session. So here the session gets generated, and in the second step, the session gets validated, or the in the when the during this validation, the password or OTP or biometrics will be validated. So it's like it creates a session, and the session is kept pending until the user enters his password on the user form. Okay. That's why authentication in transmit is a two-way mechanism. It's not just one single handshake. It's a two-way call. And we have anonymous invoke. So there is a concept called userless journeys in transmit. So where these users are like anonymously invoked, no need of user tracking. So these type of journeys are invoked based on I mean by using this anonymous hyphen invoke. And lastly, we have logout API, so which will use to kick out the sessions that are created in the server API applications. Okay. So a user make a hit, then a session basically user make a hit to the server API journeys. A session is being created, and the session is kicked out by calling the. And also you need to pass the session ID equal to session ID. Okay, and let's see the use cases for server API journeys. Okay, so day two. Yeah. So you can see like you can use like server journeys for simple ATM use cases. Like some banks are using Transmit to update the user PIN in the backend systems. So user has opted to change his PIN, and user has entered his ATM card. He want to change his PIN. So the ATM systems will call server API journeys in this case, which doesn't require any user interface, right? So it's a simple REST API call, and transmit server API gets triggered, and it fires some APIs to update the PIN information in the database and sends the response. Whatever the ATM softwares are expecting, the response is sent to them, which is a simple use case, right? And help desk agents. So help desk. So when the user calls an help desk agent asking for help with their account, so their account might have got blocked due to multiple invalid attempts, or impersonation might happen. So in this case, the customers normally call the help desk agents, and the help desk agents will be having an portal with them. So this portal um, doesn't need to be a web portal. Also, it could be a simple uh, intranet application for them. So in internet applications, server API calls are like it's a low cost call, I would say. So you don't need an interface. You don't need a web application to interact, right? So they will be having one simple intranet application, so which is internal to them, and they can make calls to server API journeys, and these journeys can be used to check the status of a user. So where the user state is, whether he's locked, whether he's unblocked, or his account might have in risk. So all this information they can check by calling a simple server API journey. And yeah, you can use it for fire and forget services also. Like you want to fire it, and then you don't want to bother about the response. So you fire these APIs to make some updates on the DB, then you can use server API journeys. And yeah, you can see transaction checks, payments and billings, alert triggers for HRT, high risk transactions. For example, if somebody has changed the password and you don't want to implement a web flow for that entire web flow, what you can do, you can simply call it a transmit server API journey, and the journey will trigger emails to the user account saying that, hey, you have changed your password today, and hey, you have done some update on your account. Hey, you got locked. So this kind of high risk transaction flows you can trigger by calling a server API journey without the need of having a web or mobile journeys. Yeah, so you can use IP location checks, customer support services, third party integration. So, like in all my experience, I've seen for customer support operations, server API journeys are the best suitable journeys compared to web or any other type of application. So, very flexible, very quick and reliable, I would say. Okay, so any questions, or shall we dive into application creation in Transmit? Server API application creation. Okay, I'll take that as a no. Great. So let's add one server API application from scratch. Okay. So this is what you are going to do today in the lab. Okay. Whatever I'm doing. So you will be using that to to create the journeys applications for the use cases I mentioned. Okay. So in the applications tab, you have an add application button. Just click on this and use this option, add an application from scratch, because we are creating everything from basic. And I would choose my application type to be server API. So if you just read the description for once, use these applications that wish to communicate with the Transmit platform through the server API, application REST API, such as for kiosks, ATMs, and call center applications. The use cases that I have just mentioned. Okay. Okay. I'm selecting server API. You have to provide an application ID. So this part is called the definition part. Okay, definition is the generic configuration for the application. So you are basically specifying what should be my application identifier, what should be my application name, and what is the expiration of the token that gets generated from this application, and any token that gets generated, how it should be protected. So this entire part is called, or this entire section is called definition. So without configuring the definition, we cannot proceed forward. So always definitions needs to be created and then you can go ahead. So definition is like generic configuration for an application. So the application depends on this data that we provide or we configure here to to proceed for further actions like jot release or identifier exposure to the end user. So, and headers, like if you want to add any token headers, etc. So I'll go through one by one. So application ID should be very unique. So you might be having 10 different applications in a same instance. So create your application ID in such a way that it is unique from others. You cannot duplicate, you cannot have say two same IDs for two different applications. Okay. So always use client name followed by underscore followed by the application type. So I would do something like this always. So for example, I'm dealing with city, so I'll keep like this city underscore server API. So this is how a standard application creation should look like. Okay, but in our case, it's just our training, right? So I'll use demo underscore server API. If it is web, I will use web app. If it is OIDC, I'll use OIDC app. If it is SAML, I'll use SAML app. That way you can define your application IDs. Okay, it will look unique and cleaner way. Application name. So application name is demo. So application name can be anything. So it is just for your reference, right? So when you have bunch of applications, you want to know what is your application. So you can quickly find the name and find out. Pick it up and open it instead of searching for an ID in the list. Okay. So the application name should be demo server app for training. Okay. Next comes authentication JWT tokens. So let me explain you with a flow diagram. Check and draw. Come on, I cannot use my other device. It got kicked me out. Okay, no issues. I'll explain in maybe online tool. I think I already used. Okay. Is great. Okay. 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 So normally, so JWT tokens are used to recognize that a flow is successfully executed or a transaction has been successfully completed, and in recognition to that, a JOT is released from a backend systems to client applications, basically like any client app you can say you can take. Okay. So here also in our case, so transmit is our backend system. Okay. One moment. This transmit. So transmit is our backend system. So the client app interacts with transmit journeys. And transmit journey validates the entire journey and then see whether the user is authenticated successfully, user credentials, user identity is established. Everything it checks and it generates a JOT inside its server. So it's a JWT and it signs the token. So before we go like how the JOT looks and all. So JOT is a JSON web token. So transmit generates these JOTs inside its server and it is released to the client applications with recognition to successful flows and successful transaction. So how the client will know that my flow is successful? So based on these JOT tokens. So these tokens are placed to the client browsers or sent to the client application responses to indicate that your flow is been successful. And these charts have a validity period of say 1 hour, 2 hours, up to 8 hours. You can so it's up to us like it's up to the business requirement till what time you want to basically hold this chart or make this chart available on on a server. So what is the significance of this JOT? I can simply return a JSON data. Why I want to deal with JSON web tokens? What is so great about it? So I would say these JOTs have some specific characters like expiration, claims, issued at, and it has some headers available, and it has issuer details. Okay, so simple as this. This is not a good one. Okay, just quickly, I'll just give high level. I'm not correct. Publish it.
Before you go
So
there, can I ask one question on JWT?
yes, yes, please.
Yes. So when you issue the JWT, right? So there should be a client validation also. Do we need to install any specific validation software on the client side to get this validated?
Hmm. Okay. So here transmit offers you to send the JOT token back to transmit for validation. Instead of client validating the validating the token, you can transmit exposes one token validation API. So client can send this token back to transmit API to validate it, and transmit knows that this is the token I have released. So and it can validate the signature of the token and then probably return the decoded content or claims from the token back to the client. So client doesn't need to validate this. Client can depend on transmit to validate. So in
Okay, but
normal cases, yeah, I understand your question. So in normal use cases like the tokens released by the backend systems or IDPs
Right.
should be validated at the client side.
Right.
So yeah, that's possible. So you can validate the tokens at your side. So but transmit doesn't offers any softwares or any logic for that. So probably you should have a JavaScript library that can decode a jot or verify a jot. So it's a crypto library
Yeah,
that is
because
available.
most of the our applications are using JATs, and JATs are being encrypted ones. So we need to decode and then validate it and go back and say, okay, I know this is the right session to use it.
Hmm.
Move forward.
Yeah.
So that's why I'm saying how is going to happen here. So transmit itself is going to validate it by doing
Yes.
that client validation. Okay.
Exactly. Yeah. Yeah. So client can depend on transmit to validate its token. Uh,
Okay.
okay. So normally, but if the client wants to validate the signature, then probably they can decode it and get the header
Yeah.
information, and
Yeah.
they can validate the XYT value, and they
Yeah,
can.
because yeah, we are using a lot. We are using the headers. We are encrypt the certificates, and all these are going back and forth. So we have to use that on a client side because we are dealing with CIM, which is client business, not
Mhm.
hosting business.
Right. Okay. Got it. Got it. Yeah. Probably we can do that. So either client-side validation is feasible, or you can depend on transmit for validating the jot tokens. But transmit will be the owner of these tokens. Transmit manages the life cycle for these tokens.
Understood.
Yeah. Okay. Where was I? Yeah. So, like as I said, the jot has some specific characters which makes it unique on an authentication flow. Okay. So what I was doing, yeah, save it, make it false. Okay. Now I can generate one. Okay, so this is a jot token. Okay, this is how the jot token looks like. So I'll copy this jot. This is not an encrypted jot. So if it's an encrypted jot, I cannot decode it because I need a signature, public key to verify it. So there is a site called jot.io where you can uh, copy paste your jots and see the decoded content inside it. Okay, Control V. Yep. Yeah, this is the header information. So every jot has two things. One is header and the other one is payload. Okay. This slider is killing me. Yeah. So so every jot has basically two parts. One is header and the other one is payload. So header has like what type of algorithm used to encrypt or to generate the jot. Here you can see it is HMAC or hash 256. So 256 bits of hashing has been done on the content on this content basically. So this payload is generated in the transmit during the uh, runtime of the journey. So the journey executes so the journey basically generates this payload, and then it converts this payload to this hashed content. So this is a hash 256 based content. So this content is what we're calling it as a jot token. Okay. So it's secure, safe, and nobody can see over internet. So even if your application is exposed on the internet, so these jots can be encrypted, double layer encryption can be done, and nobody can probably see what is there. So even if this jot lands in somebody else's browser, they cannot do anything. They cannot validate this token because it's secure, right? So they need a public key to verify the signature and see the contents inside it. Okay. So always use encrypted tokens. Do not go with HMAC tokens because it's not secure. It is only for intranet applications. Applications dealing only inside an organization level. Okay. So for example, as I said, a customer support application, which is not exposed to internet at all. So, but when we are dealing with client-facing applications or banking domains, so to not use HMAC. Okay. So currently, I think for this application, I am using HMAC. So it's hashing mechanism algorithm to create a token. So this is not safe. Okay. So these are the token hooks. And as I said, what makes a jot unique? So it has these properties like subject is the one who has generated this jot, and it has a device session ID, like who initiated. So which device. So each device has a session ID created by the transmit. So that is injected inside it, and it has an issuer. Issuer is the one who is issuing this token. So TS is nothing but transmit. So transmit is issuing. It's called ISS. We have policy ID. So here default auth is the journey that created, I mean, that generated this chart. So that's why policy ID is getting reflected, and params. So if you want to include some custom data, sorry, not custom, sorry, this is params. Params is not custom data. So it's like whatever the request params I'm sending from my side can be injected in the jot, but this is not safe feature. So because in real times you will be having huge request payloads, so you cannot put it inside a jot. The jot structure will be very huge, and it will not be easy to manage. So then, and also it is not secure to put request params inside a jot. Okay, do not you should not do that. And we have audience. So audience is the application ID. Basically, no, so this is not our audience. This is audience. Okay, which is okay. So this token is intended. Audience means so to whom this token is intended for. So this token is intended only for this application. Server API underscore test. Okay. So next is policy version ID. That's fine. And next is expiry. So we have expiration. So this is the time at which this jot basically expires, and this is the time at which the jot is issued. I'll also show you like how we can view the expiration and issue at time. Or probably I can quickly show you here itself. So just copy. So the expiration and issued at is in milliseconds. So what you could probably do is use Unix epoch time converter. You can use this one. This is a very good site to convert milliseconds to current time. Paste it. Yeah, in 25 minutes. So in 25 minutes, this jot is going to expire. So these are you can find out when.
how do you set up this in AWA in the transmit one? Because you can generate by multiple jar. JWT also have their own jar versions to create it. How do you generate here?
Yeah. So here we have an option in the definition part. We have an option to create a jot. So that's what
Right.
my next uh,
Okay. Sorry.
session. Yeah.
Go ahead.
Yeah. Yeah. So before that, I just want to make sure like everybody understand what is a jot. That's why
Right.
I'm explaining this. Yeah.
It's actually just to everybody understand. You just a predefined structure of your request, so you know where it's coming, why it's coming, what
Yeah.
kind of mechanism using. It's kind of history of your request. Everything should be stored here, but it is encrypted. Nobody can read it.
Yeah. It's secured. Yeah. Next is issued at. So this is the time at which this jot was issued. So it would be, I think, 3-4 minutes back. Yeah, 6 minutes ago. So 6 minutes ago, I generated this jot through transmit, and it gets expired in 25 minutes. So how this expiration is set, how this jot is being generated, is what we define in the application definition section. So let me start creating it again. I'm creating the application again. So replay. Yeah. So demo underscore new application name. So yeah, here you can see control the creation and protection of the jot created on successful completion of journeys and auth script functions. So here you can basically configure how the jot, what should be the expiration time of the jot, and how the signature should be added, or how the jot should be signed, digitally signed. So can be configured here. So the transmit, I mean transmit generates the jot in the background by using all this information. So we just need to tell transmit that this is what we need. This is my requirement. So this is the expiration time I want to keep. This is how my jot needs to be signed. That's it. And this is the token header. So if you want an additional headers in the token, so we have seen it has a header and payload, right? So if you want to add an additional header into your tokens, then probably you can add an additional header as well. So, okay. So here we have again two expressions. So the jots can be created by auth script. So you can use an auth script expression. We have crypto libraries available in the transmit server. So you can use auth script functionalities, which are part of these crypto libraries, to generate a jot. That is one way. So for that, also you can specify a different expiration time. So this expiration time is for jots generated through auth scripts. These are default application jots, I would say. So the moment you complete the journey, you don't need to create any expression, you don't need to write any auth script to create the jot. This jot is created by transmit automatically. The moment the journey execution is completed, transmit server generates this jot internally and then assigns this expiration timing. So 1800 seconds is 30 minutes. So you can reduce or increase. So, or you can just remove everything. You can even configure short period jots as well, like 10 seconds, 20 seconds jot also. For example, you're sending magic links to the users who are registering for the first time, and you don't want the link to be like valid for more than 20 seconds or 30 seconds, or maybe not more than 1 minute. So in that cases, these jot tokens are useful, I would say. So we can tie up this short-lived jot tokens and send it to the user application. And the moment the user click on the link, the control comes back to the transmit, and the request envelope will be having a jot, whatever jot we are sending, right? The same jot will be sent back to transmit, and transmit will validate whether the request is coming back in less than 10 seconds or not, and it will check whether the jot is expired or not. If the jot is expired, then the link even if the user has clicked on the link, the user cannot proceed forward because transmit returns an error to the client application. So that way we can make use of short-lived tokens. So prescribed timing or suggested time is 1800 seconds by default. We can manipulate it according to our business needs. Okay, so currently I'll keep it at 1800, and this is for auth script. So I'll show you how to generate jot tokens using auth script. So this will be very useful when you don't want to deal with application tokens. So this is also an application token. So this we call it as an application token. This we would call it as a journey specific token or a custom token. Okay, and the evaluation is same again. So the both the tokens will be evaluated in the same manner or same mechanism, but the generation style is different. That's it. Here we have less hassle. We don't need to do anything. Here we need to maintain. I mean, we need to write the logic. We need to specify the jot creation in the journey side. Okay, cool. So next comes signature. So how we want the jot to be signed. Okay. So I need to explain about signing mechanism now. Okay. Then probably you will understand what is signing. Okay. You can stop me if you feel that you know all this. Okay. But I'm still this for the people who are like who might not be aware of the signature signing, etc. Okay. 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 So signatures so normally the significance of a signature for any valid entity or resource is used to make it unique, genuine, and legitimate. So, for example, say you have a document issued, or it's a policy. Okay, so it's a policy issued by insurance company, and here you will be asked to put your signature, because the moment you put the signature, this document becomes legitimate, tied to your identity. So so basically nobody can tamper this anymore. So because it's your signature, you signed on it. Tomorrow you can come and say, hey, I have signed on it. There is my signature. You can see, right? This belongs to me. So nobody else can have ownership over this document. So this is something you owned it. So that is how you can say that signing the document or digitally signed tokens, or to prove that the legitimacy of to prove the legitimacy of an entity, signatures are used. So these are manual signatures that we do on documents. In cyber world, we use digital signatures. That is the only difference, I would say. And here we are using pen to sign it. Here we'll be using private keys to sign it. That is the only difference. Okay, so I will give one more example, so which will uh, have more clarity on it. So probably I need to log into my other device where I can draw better. Just give me a moment. Okay, maybe later. It's taking so much time. Okay, so I'll give probably one more example. Okay, so you have issued a check to someone, or somebody have issued a check to you. Okay, there is a check. It's a bank check, and they have written some money on it, like say 10,000, 10K rupees, and they have put their signature here. Okay, they have put their signature here, and this check is issued to Chandra, okay, in the name of Chandra, and this is the money, 10K money, and he has provided his signature. So now what I would do, I would take this check, I'll go to bank and say, hey, I have a check on my name with this much money. Can you please issue me money? So I'll just hand out this check to the banker. And what banker would do? Okay, buddy, I will give you cash, but how should I know that this is a genuine you or it's not tampered? So what banker would do? He will basically verify this signature with the one which is sitting in his which is available in his DB or in his records. So if the banker verifies the signature provided by the issuer, he's the issuer, right? So some good guy has issued me 10K money. So he's the issuer. The issuer has signed on it and hand it over to me. So I have handed it over to the banker. Now the banker verifies the signature provided by the issuer matches with the one uh, that his records has. So the issuer might have already registered his signature in the banker at the banker side. So the banker now verifies the signature that the issuer has put on and the signature that the banker holds or bank records holds matches. So if both the signature matches, for example, this say we can call it as X, and we can call it whatever the banker is having is called is Y. Okay, so Y should match with X. Okay, then banker will be happy. So banker will issue money to me. So the 10K money will be delivered to me. So here, what is happening? So in the see here signature validation is happening. So here, the issuer is signing. So the issuer is using his issuer is signing, and this signature is validated by the banker with the record against the records that the bank holds. So here, what is X? What is Y? So here, X is a private key part. So whatever issuer is signing with, right? The issuer is signing this jot with his own private key. Okay, so he will hold his own private key. A moment. He will hold his own private key, and this key will never be exposed to anyone. Okay, but how a banker would verify if the private key is not exposed? So if the private key is not exposed, so the every private key also holds a public key part. So there is something called PUB key. So this public key needs to be shared with the banker already. So that is the public, so that is called Y. So the public key that bank holds is a signature of this user, where when the user registered initially to the account, so user has to provide his signature to the banker, right? So that is the public key. So you would say, hey, you can use this public key always to verify the signature that I am providing on the checks. So whatever checks I'm providing, so I'll be issuing 2 to 3 checks every week to different people. So please verify the checks with the public key I have given you. So here Y is the public key, or the signature that user has registered in the banker side is the public key, and the user and the issuer or user who puts the signature on the checks directly is the private key. Okay, so this private key and public key are now created, can be created in the transmit side directly, or we can just maintain public key part. For example, if transmit is the owner of, so here who is the owner of the check? The issuer. His name can be Alex. Okay, so here Alex is the owner of the check. Okay, that's why he owns the private key. So in transmit side also, transmit is the owner of the jot. So who should own the private key part? Transmit, right? And who should own the public key? The client who is requesting for this jot, right? So when transmit generates the private key, it should also be responsible to generate the public key to the client application, so that the client application can verify the signature of this chart. So if it fall, so for example, say if the same check is like somehow Chandra loses it, and this check goes to somebody else. Okay, and what he does is we want to make some changes to the signature. Okay, so I mean, he has given me, for example, he has given me a blank check. So Alex has given me a blank check. There is no signature put on this. Okay, and somehow I missed it. So I was actually on the way to Alex home to ask him to put his signature, but somehow I lost it. So this signature is blank. So nobody signed it. Okay, and now the impersonator or somebody who has got hold of this check will make will try to forge this signature. Okay, he'll put this same signature. He knows Alex very well, so he thinks that okay, I can forge his signature. So he will do some tweaks and put his sign. He'll put his sign. Oh, sorry. He'll put his signature. Like he'll try to impersonate, or he'll try to forge the signature similar to Alex. Okay. Now he will say, "I am Chandra. I will go to the bank directly and I'll say, hey, can you please issue me 10K? Banker will say, sure, why not? But now the X will not match with Y the because the X that user has tampered is not matching with Y, because he in banking it's just a signature, but in digital world it is public and private key, right? So every X has only one Y. You cannot have multiple Ys. So here that's why the signature will never match, even though the banker, even though the user like tweaked his signature or he done a lot of manipulations, it doesn't matter. The Y will never match, because the private key, every private key will have only one public key. So it's like a very complex equation in the digital cyber world. So like there is an x and y on the quadratic equation, so it should match. So there is a lot of math around this. So there is always one x and only one y that exists for one private key and one public key, one in a private key and public key pair. Okay. So this is the like background of using signatures in the digital world. Okay. So now let's see how we can correlate this in our example. Okay. Yeah. So here now you are generating a jot. So who is the owner of the jot here? You guys need to tell me. Who is the issuer here?
Yeah, transmit you can
Correct.
say.
Yeah. So transmit is the issuer. So who is going to sign it? Transmit, right? So transmit needs to sign the jot, because transmit is the owner of the jot. So transmit. So here jot is like the check. Okay. So I'm issuing the check to my client. So I'll sign this jot with my own private key, and I will, if required, client wants to validate it, fine. I'll give the public key to the client. If the client doesn't want to validate, it want to depend on me, still fine. Just send the jot back to me. I will validate because I have the public key with me. Okay. So even if transmit validates the jot or the client validates the jot, the public it has to verify the jot signature with the public key only. If the public key doesn't matches with the X, then that's it. You cannot verify the jot. So the signature validation will probably fail. Okay. Fine. So in order to sign with key, you need to add a key. So in order to add a key, you can probably go to platform keys and credentials and add a key, or you don't want, or you can directly add from the definition also. Okay. So here now I'm creating public and private key in transmit. Okay. How that is done? Click on add key, and you can see you want to generate a key using transmit, right? So you can use generate key, or you already have a public and private key generated by a secure open SSL source. Say you have creds authority soft creds. I mean, there is one software called creds authority, so which can generate public private key for your organization. So you don't want to depend on transmit to create private and public key. You can create one, and then use that private key to be uploaded in transmit, so that now transmit will maintain that private key in its key store. Okay. So either you can do that, or you can upload a private key in the format of .pem file. Okay, because the client don't want to trust transmit. No, transmit, I will not trust you, because what are the private key you create, it is not so secure. So I will give you the file. So you just maintain that, and I will hold the public key, and I will make sure the signature matches. And that is my digital authentication mechanism. So this is how I can trust the tokens that you generate from your side. So that you can do that as well. So if it's a PEM file,
Does
you
it
need to
does it support for AWS certs? Open source
AWS.
AWS.
Yes, it supports, but it should be in a .pem or .key store, JKS
Dot
file.
key store. Yeah. Yeah.
Yeah,
Okay.
it supports Vinay. So I have I have tried Azure AWS certificates. So in key you can create one from the AKV, right, and then use it here.
Right.
Yeah,
Because those are free source, right? So those are open source. So just want to make sure it's not like only
yeah.
transmit specific one. Okay.
It doesn't mean it doesn't matter for transmit, like, but only thing is the certificate should be a valid signature, valid certificate. That's it. Whatever the certificate we upload, it should be in a valid format. Yeah, and it should be basically X509 format if you're dealing with a PEM file. Yeah.
Yeah,
Now
but you know, right? You issued AWS. The Amazon has a way of generating the certs, right? Because
yes,
those are
yes,
free. So those are the one you generate, and you can keep those on the both the sides.
yeah,
So just want to make sure it supports here. Okay, thank you.
yeah, it supports. Yeah. Okay, so now we'll go with key generation in transmit. So transmit will now generate key for us, public key for us, and private key. It stores in its DB. Private key is never exposed outside the transmit DB. Okay. Key alias, it can be token signing, version one, key type. So yeah, you have to provide some version to the key, because in future if you want to you want to update you want to make some changes to the token that you private key that you create, you want to increase the expiration for that. So probably you can use version 2 in future. So that's why you can maintain even versions for the private key, public key that you create in transmit, that you generate in transmit. Jot key ID is optional, not required. Key type. So key type, always go with RSA. So RSA algorithm is powerful enough to generate most unique and sophisticated complex private keys. So I'll always go with RSA. Key size. If you want to make it more secure, go with higher lengths. That means, so 1024 is almost like they are padding 1024 bits to your token. Okay, sorry, to your private key file. So 1024 bit private key file will be generated. If you want to go with 2048, it will generate a private key of length 2048, and more than that. So like, see, 1024, to decode 1024 private key, only if any user has even the public, if any user wants to decode. So to decode 1024, it will take almost 100 years for him to decode it without a public key. So that level of security 1024 bits provides. So just imagine what level of security 2048 and 3072 can provide. So like 1024 should be fine for normal applications, but if your client expects more higher level of security, go with 2048. Okay. So for now, I'll go with 1025. So this is size of the key. Okay, the private key that you're generating, right? So that is the size. Default key usage, yes, go with default key usage. Expiration, so I'll go with always 365 days. So at least 1 year validity should be there for your certificate, and common name to be set in the certificate generated for the new key. So you can provide a valid name, for it is if it is for credit card applications, I would use credit. No, no, or I can any common name, right? Normally I'll use the same thing, key alias common name. Okay, customer certificate subject details. We don't need to customize. If we want, we can do that. Probably you can basically provide CN, state, organization, unit. So when you create a certificate in any organization, so these are the default details that we need to provide. If you don't provide that, transmit will by default have some values for this. It will be empty basically. So if your certificate validator at the client side will make sure that if the C and state organization OU matches or not, then probably you need to provide all this. So this country, state organization, all this will be injected inside your certificate or your private key file. Okay. So I'm not doing any customization on the subject because I don't deal with subject because I just deal with the signature match. That's it. So I'll click on save. Now I can see that key I created in the token signing. I'll also show this key, the same key that we created now will be visible in the keys and credentials section. Okay. And now, yeah, so now I have signature key. Okay. So sign with key. That means my tokens, when released outside, my tokens will be having the signature token underscore signing. Is the name like misleading? Let me know. I can change the name of this. Okay. So I'll just created one private key. The private key file name is token underscore signing. And I'm using this to sign the JOTs or sign the tokens that are issued from transmit side. So my JOT will be having the signature token underscore signing. So my client has to see whether the signature is token underscore signing or not. If token underscore signing matches, then my client will say, okay, this is a genuine token. I can trust it. I don't need to worry about any tamperness or man in the middle attacks, etc. Okay. And encryption. So you want to encrypt, then you encrypt. So there are two things. Okay. One is encryption. The other one is signing. So signing is digitally like digitally taking the authority of the token. Okay. So you're proving your authority on it. Encryption is that no, so you don't want your content to be exposed anywhere. So you do want your content to be safe. So only person who can see the content inside it is the one who is having the public key. Okay. So when I use encrypt using signature key, so this is signing key I created, right? So this signing with the same key, I will do encryption also. So signing and encryption are two different things. Okay. Let me show you. Okay. So signing, so this check is being signed. Okay. So this is digitally signed. Oh, come on. So this is signed. So now I don't want this check to be exposed. Nobody should see what is the signature, what is the amount written on it, who is the issuer for this, and whose name has been written as the like debitor or who is owning this check. So all these details I don't want to see, I don't want to expose. So I will check the I'll take it in my hand, and so I'll show it to everyone, so everybody will be able to see. There is the probable risk that somebody might have taken a photograph of this check without my consciousness. So and next time they'll create one check like this, they'll put the same signature, and there is a high risk that my that somebody with my name written on it and a signature of Alex handed over. I mean uh, Alex signature is forged on the check and then handed over to banker, and somehow banker believes that the signature matches X equal to Y, then he gives the amount to some hacker. Okay, so we'll put his name Dom. Okay, So Dom is my hacker. So he comes to bank, he steals my money, he steals the money of Alex. But you know who is going to be behind the bar? Chandra, because Chandra is innocent. Nobody knows. Everybody thinks that Chandra came to bank and forged the signature of Alex, but the actual culprit is Dom here. So that's why encryption is required. So you don't need to expose, even though your data is signed, you still your data is at risk. Okay, anybody can forge the signature. Possible, there is a possibility that signature mimicking the signature is possible or a network. So always make sure your data is encrypted so that even the signature information is not exposed on the internet. Okay, so that is where we do the encryption. So how the encryption is done. So we'll be using a signature key. So all this check information like issuer is Alex, and who is the audience? Audience means to whom this check is intended to, Chandra. And what is the subject? Subject is the money that 10K is the money, right? Uh, this is like one crappy tool. Please bear with me. Okay, so 10K is the subject. So the subject is give money to my audience. Audience is Chandra. Issuer is Alex. Okay. So all this information still visible if you are not encrypting your jot. Okay. So now this payload has to be encrypted in such a way that none of this information is visible. Even if I copy this jot, put it in jot.io, I should not see all this payload. This should be completely encrypted from me. Okay. Where was I? Yeah. So this information I should not see. Even the issuer, audience, subject, nothing should be visible. So what I would do, I will apply encryption algorithm on this information, and um whatever information is there, so that will be converted into an encrypted string. Okay, so it will be something like this: E Y W J X blah 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 blah. So up to how many characters you want? You have chosen 1024 bit, right? So you can generate encryption strings up to 1024 bit length. Okay, so up to n. Okay, whatever the private key file size is, so that much length the encrypted strings will get generated. Okay, so the encrypted string holds this information, but if I just copy this and put it in any jar.io, I will never come to know this unless I have y with me. If I have y, I will apply the y. I will be having a decoding algorithm with me. So from from internet, I'll download decoding algorithm, and I will just pass y as an input to my decoding algorithm, and my y will make sure it matches with the x. Sorry, my decoding algorithm will make sure y matches with x, and then it releases the lock. So here y is the key to the lock x. X is the lock, y is the key. So you can consider that way. So public key is the key to the lock of private key. So private key you can consider it as a lock, and public key is a key to open it. Okay, that's it. So do not expose public keys. So keys should be very much secure when you create an application. Okay, cool. So I hope this is clear. So now we are doing encryption. So we done signing, but it's not protected. Now we are done encryption. Now it will be completely protected. So always go with encrypt using signature key. And additional headers, it's up to you if you want to add one, but I won't recommend. Let it be the default one. So the JSON, the JOT structure should be always this, like KID type algorithm. If you want, you can add X5T. So X5T is not required for now, but for OIDC tokens, it is required. I'll explain that concept. Okay. Now I'm going ahead and saving it. Okay. So I hope this is clear. So this definition part should be defined by the developer when we are creating an application clearly. Okay. If you forget adding the key and all, it's okay. You can add it later as well. So if I use sign with matchmark, it's a default algorithm, hashing algorithm, which will which will generate jots based on by simple hashing techniques. There is no signing. There is no uh, there is no encryption. It's unprotected token. Okay, so never go with sign with HMAC. And later you want to switch, you can switch. You can just click on sign with key. Okay, so that way you can do the changes later as well. Okay, so click on save. Cool. Now my server API application is created. So as I said, once the application is created, right? So the first page you will see is the definition part. So now the definition page is bigger than the one which we have seen earlier, because the when during the creation, the transmit will show only up to this part. Once the definition is created, now transmit will show additional data that needs to be configured, because transmit don't want to put the hassle on the developer to provide all the information during the creation itself. So first it will allow you to create with basic information, then it will allow you to provide all the information later on when you configure the journeys, when you when you configure this. So these are all journey related specific, right? So that's why it will allow you the moment you want to create the journey, or you have the plan to create a journey, then probably you can configure all this stuff. Okay, cool. So yeah, double encryption. So if you want an additional layer of encryption between SDK and server, SDK is client, server is transmit. Yes, you can use that. You can encrypt all the data, which will be like encryption. On top of it, again, you are putting one more layer. So like encrypt. You already got an encrypted token, right? So they will encrypt that encrypted token again. That is double encryption. So we don't need that level of protection. Okay, just go with don't use double encryption. This doing this, what happens? It is a performance impact basically. So you're already encrypting, you're again providing encrypting, and then when you come to transmit has to validate that. So it has to remove two layers of security to see the content inside it. So which is not a good. I mean, if for when it comes to business, yeah, we have to. We I mean we want to use double encryption. So yes, you're always allowed to do that. There is no question about it. But uh, what I would say, like it could cause a performance impact if you go with double encryption layers. Okay, but that is negligible. It is not so high, but still you can keep it simple by not use going with double encryption. Okay, then coming to application reporting. So from the application, you can even control the reporting level. Okay, so you can basically say that I want to log whatever execution happened in the journey side, whatever is executed in the journey. I want to log everything. So I don't want to leave even a trace. Then you go with store full journey evaluation data in activity logs. And there is other option called store only non-sensitive journey evaluation data and activity logs. For example, say journey is dealing with some CID, client identification data. For example, user is getting authorized with an LDAP, and the LDAP returns all the user profile information. And my client doesn't want me to log this data. Then probably I can use this store only non-sensitive journey evaluation, which will skip all the authentication related data. But what am I losing here? I'm losing all the trace for authentication process. Whatever happens in my journey, I'm losing it. So I don't want to go with this option at all. So always go with store full journey evaluation data and activity logs. Okay. And now comes this default external connections. Send email using get account details from. For example, my journey wants to validate a user. Okay. And here I need to provide which database my user needs to be validated. So it's asking in prior basically. Like if you so you can so that you don't need to configure it in the journey again. So this is how it plugs in, right? So you'll understand the link when I create a password authenticator, and then route it to this definition part, and the definition will go to authentication database, and authentication database will go to the LDAP. So it's all a big route. If you're using a OTP authenticator in your journey, okay, and you want to send that OTP through SMS, then you need a service. So that service has to be pre-configured in the definition so that you can directly configure OTP authenticator in your journey. If you're not configuring an SMS service here, you will be end up generating a OTP, but you will end up not delivering this OTP to the end user. Okay. Same goes with voice, same goes with email. You can send OTPs either in voice, also I mean voice in the sense like you will get a call, but transmit is not going to call. Transmit is going to depend on a service which will do the voice trigger call, and then the OTP will be spelled to that. So it's an automated. There are automated systems, right? So which you can do the voice calls, which can send SMSs, which can send trigger emails. So like now we have Twilio. Twilio is a famous SMS provider and voice messages orchestration, and we have semantic OTPs, Google OTPs, Apple. We can use Apple services for pushing notifications. So like we can use any carriage provider who can take care of sending SMS. But I'm telling you, transmit will generate only OTPs. Okay, so it is responsible to generate only OTPs. Transmit is not going to deliver the OTPs to the end user. But transmit will provision that. It will orchestrate the flow. It will call the service provider. It will fire the service provider and sends the generated OTP in the request, and the service provider is responsibility is to deliver it to the end user. Okay, and now transmit holds the responsibility to generate and also validate. So the user enters the OTP on the screen, and it is sent back to the transmit, because transmit is waiting for the user now. So the user has to put the OTP and click next. And now transmit will validate the OTP, because I mean, it stores the OTP in its DB, right? So it will validate it. Okay, so that is the significance of default external connections. So now this is not so important. Risk is uh, very optional. So once you fill all these details, click save. And these are not mandatory fields; these are optional fields. Only the moment you create 10 password authenticator, then probably you need to configure this. Okay, so I'll go ahead and click save. I'm good. So now I'll go to identity journeys. So okay, so now you can see this is my uh, application ID, and this is the type of the application, and this is the name of my application. So see, this is a template of your application interface. Okay, so when you when you want to switch over applications, so you can see clearly name, that is the name, this is the type, and this is the ID, and you can choose with whatever identifier you want. Simple as that. Okay, so another 15 minutes we'll continue the session, and probably we can have a break. Okay. Okay, so now let's understand what is a journey. So journeys are basically decisioning tree models developed in the transmit engines. Okay, so this journeys holds the orchestration flow, or I would say it holds all the logical step validation features in the journeys. So these journeys are a unit of application. I would say it's a process. It's a functional flow. So you create n number of journeys. So each journey acts as a unit. Each journey acts as a functional flow in an application. So this application is collection of journeys, I would say, a collection of processes. So like in a package, how we have multiple classes. So each class has its own functionality, right? So one class might be triggering a database service. One class might be firing some APIs. So like each class might be doing something unique, not the same job, right? So if each class is doing the same job, will not keep two classes. It's a redundant job. So that same thing here. We'll have multiple journeys. Each journey cater to perform a service or perform a functionality. So we'll use a journey. But how this journey is created, how this journey is built up of. So what this journey is basically. So journey is basically a decisioning tree model, as I said. So they could have used a different technique of developing the journeys, but they have specifically chosen decisioning tree model, because normally when you get a requirement, what we would do. So we'll create a flow, right? So step one, user has logged in. Step two, uh, backend system backend system request received. Then step three, he has gone to the DB. I mean, the backend has gone to the DB. Yeah, something like this. Backend has gone to the DB, but DB responded back to the backend system. So now we'll have an if else condition like this diamond. If user has, if user is available, then user is valid. Okay, so I'll use user is valid, password is valid. Then he's successfully is successful. Then he sent some token. Okay, if the user fails, I'll send failure response back to my client application. Failure response. Failure response. So this flow is very straightforward, right? So user logs in. So log in. Step number one. User log into the application. So application kicked in the backend system. Okay. So this is a client application. Okay. This is the client application. Client has logged in, backend system kicked in, backend has validated with the DB. Okay. And the DB says, hey, this user is available in my store. So user is valid, password is valid. Then successful user gets a token. If failure, user gets a failure response. So this is how this is a decisioning tree model, right? So here we are creating a decision using if else, and based on this we are branching or bifurcating the flow, whether the user should be in success path or failure path. Okay, we are doing the same exact thing in transmit journeys. We are not writing the code. We are using nodes which will constitute to this decisioning tree model. Meaning, so if I for example, I need to collect the username coming from the request. Okay, so I'll use a node. Okay, so here each of these boxes that you see here. Okay, these are called action nodes in transmit. What do you call action nodes? So, or we can say decisioning nodes. Not decisioning nodes, I would say journey nodes or action nodes. These are the two terminologies you can use. So that's why in journey, when you create a journey, right? So you will have this plus palette symbol, and it shows these are all the nodes. Okay, these are all action nodes. Each node has a functionality, and we should know exactly how to use this. Otherwise, we cannot complete the journey flow. So understanding these nodes is a key part here. So we should, if you know the functionality, then probably you don't need to write the code. You can just drag and drop and then use it and create one decisioning flow, and that's it. You're good. Okay. So for collecting the username, what should be my node? Hitting the backend API, what should be my node? For validating this decisioning if else condition, what should be the node I need to use? And to return success response or token, what should be the node I need to use? For failure response or rejections, what should be the node? So this way you need to understand, for in transmit journey you should correlate this exactly in the journey also. So first of all, you should have clear idea on what is the flow that you're going to develop. Then probably based on that you should cater the nodes in the flow accordingly. You should drag and drop the journey nodes, and then create a flow in such a way that from start to end the journey interpreter, there is an interpreter which is uh, uh, which is part of the journey engine. Okay, so this interpreter basically goes to step 1, step 2, step 3, step 4. So it'll execute each and every part, every node basically. So every node, it is for us, it's a node. For transmit, it is a code. Okay, so transmit will convert this into a code and then execute each line of code through the journey engine interpreter, I would say. So each line, each node is been each node is a each node is a line. Okay, consider that way. So the moment the journey execution starts, each node is being interpreted, each node gets executed, and based on whatever logic that node holds, that gets executed. And